So the first question here, you are being asked to find any and all vertical and horizontal asymptote lines. Okay, so before I start, try to think to yourself, what is the strategy, right? What is the procedure we use for finding vertical asymptote lines? And that's very, very different than the procedure we use for finding horizontal asymptote lines. Okay, so I'll do the first one with you, and then I'll ask you to pause the video and try the second one. So vertical asymptote lines, we set the denominator equal to 0. Okay. Remember that when the denominator is 0, as long as there's not the same factor up in the numerator, which in this case there isn't, then this is a vertical asymptote line and not a hole. And make sure you give it as an equation, okay? Asymptote lines have an equation, so it needs to be an x equals or a y equals. If I set the numerator equal to 0, remember that when the numerator is 0, that's when the function itself is 0. That's when we have an x-intercept, right? So sometimes students will mix that up like, oh, if I set the denominator equal to 0 for vertical asymptote line, then I should do the numerator for horizontal asymptote line, and that's nowhere even close, okay? So remember, for finding horizontal asymptote lines, we have to see if there's some place that the function levels off, okay? Which is why we look at what happens as time goes on and on and on. So we have to consider both positive and negative infinity, although the answer in this case would be the same. And notice here, I'm rich. I don't care about $3 or $6. I look right here and I see that this limit is 5/2. Okay, so if the limit is 5/2, then this first function has a horizontal asymptote line at y equals 5/2. Okay, so pause the video and try the next one. Okay, and if you're back, setting the denominator equal to 0 here, that would factor into x minus 5, x plus 5. Okay, so we have two vertical asymptote lines, one at positive 5, one at negative 5. Okay, so x equals plus or minus 5 for our vertical asymptote lines. And then since the degrees are the same, we look right here. We're rich, so we don't care about $2 or $25. Throw those away. Look right here. That simplifies to 3 when we're taking the limit as x approaches infinity. So y equals 3 is our horizontal asymptote line. Okay, then we've got our rules about top heavy doesn't have a horizontal asymptote line, right? Those functions either go to positive or negative infinity. Bottom heavy always goes to 0, right, when we're looking at limits to infinity. And then as we just saw here, if the degrees are the same, the limit is the ratio of the coefficients for the term that has the highest degree. Okay, so why don't you pause the video and try to do these next 5 problems. So going over these, I'm going to start at where we're bottom heavy. Right here. Everything bottom heavy goes to 0. This one, this portion, if I have one cookie and a billion people wanting to eat one cookie, this portion goes to 0. So in a sense, this one's bottom heavy, and yet we're left with the 9, right? The 9 tags along at the end. So that one's just positive 9. All right, then I'm going to look for the one that's top heavy. Okay, the one that's top heavy, right? So the number of cookies grows faster than the number of people showing up to eat the cookie. So I'm going to end up with lots and lots and lots of cookies, right? That would simplify down to x, and x is approaching infinity. So this function keeps on growing. Okay, so this function would not have a horizontal asymptote line. All right, then we go over here. Both of the two that are left, the degrees are the same. Because remember, I'm rich. I don't care about $3. Well, then that's just x over x, right? Degrees are the same. That's just 1. Okay, that limit is 1. And then anytime I give you a problem, if it's not written in standard form, we have to pick out that term that has the highest exponent, right? Because when x is large enough, everything else compared to x squared, 5x would get left in the dust and so on. So these are our only significant terms here. And then the ratio of these coefficients, be sure to take the negative with it, -3/2. Okay. Then come down below, and this is a fun problem. This one asks you to fill in the numerator with any polynomial that would make this have a horizontal asymptote line at y equals 1. Okay, so in other words, I would have to take the limit of this function g of x as x approached infinity, and I would need that limit to be 1. Okay, and then this one down below, I want a horizontal asymptote line at 0. Okay, so I need to be able to take this limit and have it be 0. Okay, actually there would be infinitely many things you could put in that numerator. So pause the video and think about what you would need to put. Okay, so coming back to 15, we would have to be able to look at the leading coefficients and have the x squareds divide out to leave me with 1. All right, so I would need something here that goes 2x squared. I could have just 2x squared and that's it, or I could have 2x squared plus or minus, whatever I wanted to put here, as long as it was as long as it was either an x or a constant. Okay, I can't do any other squared terms, or I can't have a cubed term or anything like that. So if I put plus 5x minus 7 or something like that, that would work. So 2x squared plus or minus whatever other linear terms you want to put, or constant terms. Okay, now down below, we want this to go to 0. That means it has to be bottom heavy. I could actually just put a 1 in the numerator, right? That'd be bottom heavy. Or I could put in x plus 1. Okay, so as long as I have something, either a constant or just something with an x to the first power in the numerator, then you're good. If you have an x squared in the numerator, that won't work. Okay, so anything 5x plus 10, 7x minus 3, just an x, right? Anything like that would work. So again, I hope you found this helpful, and thanks for participating.